Have you ever made a wooden boat? Right now, I'm at a wooden boat race, and it's super fun. But seeing these little wooden boats going down the stream does make me wonder, how do actual boats that are made of heavy metals float? Hi, I'm Annika, a second-year student studying creative technology and design at CU Boulder. Today, let's explore how exactly engineers have made giant boats able to float, and let's learn about buoyancy. One of the things that affects whether something will float or not is an object's density. Density is the mass per unit volume of a substance, or mass divided by volume. Essentially, density is how heavy an object is relative to its size. At the simplest level, if an object is more dense than water, that object will sink. And if an object is less dense than water, that object will float. However, we just mentioned that boats made of metal, which is much denser than water, are able to float. And this is because of what we call Archimedes Principle, which states that an object submerged in a fluid experiences an upward force called the buoyant force equal to the weight of the fluid it displaces, or pushes out of the way. In other words, when something pushes on water, the water pushes back, and this is due to something called water pressure. Think about it like this. If I make a stack of boxes, gravity is pulling each box individually down toward the box on the bottom. The bottom box experiences the force of all those boxes being pulled toward it, and we call the force of the other boxes pushing on the bottom box pressure. And while the bottom box experiences the most pressure, every box is experiencing at least some pressure from the boxes above it. Water experiences this same thing. Water near the top has less water above it, and thus experiences less pressure, while water near the bottom experiences more pressure. Although water pressure actually works in all directions, not just downward. When water experiences pressure from something, water, air, an object, whatever, the water puts pressure back on that thing. When you have an object made of something less dense than water, the water pressure will always be strong enough to keep that object afloat. Although different materials may float at different heights, styrofoam, for example, is so light that it can float right on the top of water, where the water pressure is less because the water there is experiencing less pressure. Wood, which is heavier than styrofoam, has to sink deeper into the water where there's more water pressure before it'll float. So, when you put a toy boat into a bowl of water, gravity is trying to pull it downward, but water pressure is pushing it up. And we know, thanks to Archimedes' principle, that the buoyant force, or the amount of pressure the water puts on the boat, is equal to the weight of the water that's displaced by the boat. If the boat's material is less dense than water, it will float. Otherwise, as long as the weight of the water the boat displaces is greater than the force of gravity acting on the boat, which we describe as the weight of the object will float. So that's the science. But what does that mean for designing ships? How can we build ships that use Archimedes' principle and water pressure to float? Well, let's find out. We know that water pushes upward on an object with a force equal to the weight of the water that's displaced by that object. So, to make an object like a boat float, that boat just needs to displace enough water that the weight of water displaced is equal to or greater than the weight of the boat. And we can control how much water a boat displaces by controlling its shape. There are many common shapes that our boats take. One kind is the flat-bottomed boat. These boats have very wide, flat bottoms, which displace so much water and have so much surface for water pressure to push against that they can float very close to the surface of a body of water. As long as you distribute weight on one of these boats evenly, they can carry a lot of weight. They're also easy to build and don't go deep into the water, so they can be used in shallow water. Another common shape of boat is a round boat with a keel. The bottom of these boats are round, and engineers determine exactly how they need to be shaped to displace enough water to ensure the boat can still float using math. These boats also have a ridge along the bottom, which we call a keel. Without a keel, a round boat would fall over easily. With a keel, the water pressure pushing on the keel is strong enough to keep the boat upright. These boats can move faster than flat-bottomed boats, as the water can easily flow around them, but the keel means they can't go into very shallow water, and these are more expensive to build. There's also multi-hulled boats, which are boats with multiple kinds of bottom. These come in all sorts of shapes, and are generally very stable because they're wide. However, because these boats are the most complicated kind, they're usually the most expensive to build. Another thing we have to consider when making sure our boats float is where we put added weight. Let's say we have a flat-bottomed boat, and we wanted to put a heavy cargo box on it. If we put that box toward one of the edges, the boat is going to tilt, and if it tilts enough, it'll fall over. Instead, we need to make sure our cargo is toward the center of the boat. What if we had a round-bottomed boat that had a bunch of decks and was super tall? Well, just like with our flat-bottomed boat, we still want to keep the weight central. However, for a taller boat, we also have to worry about the height at which we put the weight. If we put the weight too high, it increases the likelihood of our boat tipping due to a particularly strong gust of wind or a big wave. So we want to keep the added weight low as well as central. In fact, some ships carry ballast with them, which is just extra weight added to a ship specifically to keep its center of gravity low and central. With ballast, you can worry less about where exactly all your cargo goes, as long as the ballast stays much heavier than your added cargo. Because of the special property of water pressure, as long as we shape our boats to displace water and are careful with where we put extra weight, engineers are able to make all sorts of boats for all sorts of purposes. And now you know about Archimedes' Principle and buoyancy, so you can make your own boats too. Oh, I better hurry over. It looks like the boats are about to reach the finish line. Thanks for watching, and until next time, don't be afraid to dive into the awesome world of engineering. Check out the full lesson on Teach Engineering. Then use what you learned in the associated activities, clay boats and buoyant boats.